Mathematicians, gear up, as today we talk about finding common units or number of units to help us compare two fractions. Let's get into it with our I will statements.
Remember, your I will statements are your goals for this lesson. They are what we are trying to work on and learn more about throughout our time together today. As we continue on in our lesson, make sure you have your mind focused on these three things and showing them to your teacher. I will read the I will statement first, and then we will read it again a second time together. Make sure you're reading it nice and loudly so I can hear you, but no shouting necessary.
Listen as I read the first I will statement. I will write a number sentence comparing two fractions. Read that one with me. I will write a number sentence comparing two fractions. Let's look at the second one. I will compare area models. Say that one with me. I will compare area models. And our last one. I will represent a fraction in an area model. Nice and loud. Ready? Let's go. I will represent a fraction in an area model. Nice job, mathematicians. Let's get into our warm-up. All right, mathematicians, for our warm-up activity today, you'll need your own personal whiteboards. We're going to work on comparing fractions. On our whiteboards, let's write 1/2, put a line in between, and then write 3/4. Write that on your whiteboards now. We are going to spend time comparing this fraction. How we'll do that, you'll ask, is we are going to find a common denominator, and then to show which fraction is greater, we're going to write either the greater than or less than sign in the middle. So you'll pick either this sign or this sign. If we were looking for a common denominator for these two numbers, we can list out the factors of 2 and 4 until we get to the same one. If I list out the numbers that 2 go into, they go 2, 4. Since 2 goes into 4, I don't have to do anything to 3/4. And I have to change 1/2 so that it has that common denominator of 4. When I think about what I need to multiply 2 by to get 4, I multiply 2 times 2 to get 4. So since I did that to the bottom of my fraction, I have to do it to the top of my fraction. What's 1 times 2, everybody? 2. Now that I have common denominators, I'm able to determine which symbol goes in the middle by just looking at the numerators. 3 is bigger than 2, so I am going to choose the less than sign, so it shows that it's opened mouth towards the 3. It wants to eat the 3. It's a bigger number. Let's clear our whiteboards and try a few more. Now let's try 1/2, and we're going to compare that to 3/8. Remember, we need to find the common denominator first and then write if it's greater or less than. Let's write our denominators on the side. We have 2 and 8. Let's start with 2. 2 goes into 2, 4, 6, 8. Since 2 goes into 8, I don't need to change 3/8, but I am going to need to change this 1/2 so it has that 8 as a denominator. We need to make an equivalent fraction to 1/2. I can think what I multiply 2 by to get 8. I do 2 times 4 to get 8. Since I multiplied my denominator by 4, I have to do the same to my numerator. What's 1 times 4? 4. Nicely done. Now we can just look at our numerators to compare our two fractions. What's the bigger number, 4 or 3? 4 is the greater number, so I am going to want to put the greater than symbol to show an open mouth towards the 4. We are going to continue this activity, and I am going to show you a few more fractions to compare. Your job is going to be to find common denominators in the fraction and then write either the less than or greater than sign to show which one of the fractions it is equal to. Clear your whiteboards, and I'll show you those warm-up problems now. It's up to you, mathematicians. Compare the following three problems. 1/4 compared to 3/8, 5/6 compared to 1/3, and 1/3 compared to 2/9. Pause the video now and come back when you're ready to see the common denominators and the answer to the correct comparison and symbol to put in the middle. I'll see you in a second. Here are the common denominators that I found for the fractions and the comparison signs that go with them. You could have found different common denominators for these fractions, but they would have come out to the same symbol in the middle. Let's wipe off our whiteboards, give a stretch, and get ready for our activity for today. All right, mathematicians, let's talk about comparing two fractions with unrelated denominators using an area model. On our whiteboards, let's write these two fractions, 3/4 and 4/5. We have compared fractions, but using benchmarks to help us reason. Another way to compare fraction is to find like units in your fractions. We're going to draw two almost square rectangles that are the same size. Each is going to model 1. Let's draw those on our whiteboards now. Draw your rectangulars to look similar to mine. Remember, we're not artists, but we want them to look almost the same size. For our top rectangle, we are going to split it into fourths vertically. So we are going to need to draw 3 lines to partition our one hole into 4 parts. And we are going to take away 3 of those parts by coloring them in. That represents our 3/4. Now we need to look at our other area model, and we need to partition it into fifths. We are going to partition it into fifths using horizontal lines. Horizontal lines, remember, mean going left to right. We're going to need to draw 4 horizontal lines to partition our shape into fifths. I'm going to repartition mine so they look a little bit more equal, which is fine. If you need to fix your shape, you can fix your shape along the way. Now we need to shade in that we have 4 of those 5 parts taken out. Now, if we look at our denominators here, thumbs up or thumbs down, do we have like denominators? No, I should see thumbs downs in the crowds. We have 3/4 and 4/5. We split our top picture up into 4 pieces and our bottom picture up into 5 pieces. We're going to work with our 3/4 first. Let's partition each fourth into 5 equal pieces. So to do that, we are going to draw 4 lines across. Let's just draw dotted lines. Put them across our top shape. 1, 2, 3, 4. Now, if we were to count how many squares we just made when we added those dotted lines, let's count together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We just made 20 new units now. So now our whole represents 20 units. If we were to look at the value of one of these units, it would be 1/20. Now, how many of those 1/20 are shaded in? So we need to count how many boxes are shaded in. Count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So now we have 15 shaded in pieces out of 20 total pieces. Now let's decompose 4/5. We're going to partition each fifth into 4 equal pieces. So we're going to draw 3 dotted lines on our 4/5. Now, if we were to look at this, we made 20ths again. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We did make 20ths again. And if we were to count how many were in the shaded area, pause the video and count how many you have shaded in on the bottom. Come back when you're ready to see what's the answer. The correct answer is 16. 16 is the number shaded in on the top, making 16/20ths equivalent to 4/5. Now that we have common units, we can compare our two fractions easier. So we can compare 15/20ths compared to 16/20ths. We have common denominators, so we just need to look at the top numbers. 16 is greater than 15, so we are going to draw our less than symbol here. Now, if we wanted to represent this as our original problem, we're going to write so. 15/20ths was equal to 3/4, and 16/20ths was equal to 4/5. And we have to bring our symbol down. Since these are equivalent fractions, it's going to make it the same statement in the middle. So when we think about decomposing 4/5 and 3/4 to compare, we had to make common units so that we were able to compare the fractions. First, we drew our area models to show the original fraction. Then we had to partition one using vertical lines and the other using horizontal lines to model each of the new portions. We split this one up into fifths because that was the opposite denominator. We split our 4/5 up into 4 pieces because that was the opposite denominator for the fraction we were comparing it to. Then we partitioned each model again. That's when we created our new units. Once we had those like units, they both turned out to be 20ths, we were able to compare the fractions. We compared 15/20ths and 16/20ths. Then we were able to figure out that 15/20ths was less than 16/20ths. So we were able to conclude that 3/4 is less than 4/5. You're going to continue practicing partitioning up your fractions and decomposing your area models to find common denominators to help compare your fractions. Good luck, Matt.